Hello everybody. Just a quick video about how to set up Arduino with your computer and how to use MATLAB to control the Arduino. The first thing that you need to do is actually you can control the Arduino using the Arduino software, which you can download from this website right here, arduino.cc/en/software, and you can go to the website and then you can download the version which is appropriate to your computer. We download that and you can open it. You can test your board, Arduino board, by going to File, Examples, Basics, and Blink. Is actually gonna blink the board without any other connections that you need. Once you do this button right here starts compiling, and once it's complete you can upload the code to the circuit from this button right here, the second button on the from the left side. I'm not connecting it right now, so it's giving me errors, but anyways, this is how you're gonna test your connection to the Arduino board. Once you do that, you can just close this out and go to MATLAB and then start. The first thing is you have to download a special add-on for Arduino, which is going to be here, manage add-ons, and then you can just type in Arduino in the search box if it's not installed. Those are the tools that the toolboxes that are already installed in your system in your MATLAB. If you want to search for something, just type in the name, the keyword that you're looking for, and if it's not installed, it's gonna show up here, and you can just install it or set up whatever, and then you install it. Once you install it, you'll be able to control your board through MATLAB as well. The first thing is you have to set up a connection from the MATLAB to the Arduino. The line that is responsible for that is basically this line right here. If you have a Mac, you have to do it manually because it does not recognize what port it is connected to in Mac, or maybe certain computers as well. But for my computer, which I'm using Windows 11 laptop, so it's gonna be connected automatically. What you need to do is not for this specific code, but usually if you want to set up a connection, you can just type in A, which is a variable that we're defining as the Arduino board. And then you don't need to do that if you're using a Windows, because this is for the Mac users. So that's a directory in for Mac users that is not actually recognized in Windows, so you don't need to do that. So when in Windows, it recognize or it identify exactly where it's automatically, so you don't need to put anything inside those brackets right here. Okay. Once you do this, you have established the connection between your computer or MATLAB and your Arduino board, and you're gonna use this variable to say, well, send a specific command to the Arduino board. Okay. The first line in MATLAB is basically clear, means clearing all the variables that are on the memory right now. For example, if I have x equals 0, this is a variable that is created. Okay, so in order to make sure that there are no other variables already stored in the system, I have to clear it using this command right here. So I'm gonna execute this, and you'll see that it's already cleared right here from this command. You see that the clear function has been executed right here. Okay, the CLC clears this window right here. You can use it from here, or you can just type it here, CLC, and it clears the window. The CLF clears any figures already opened. Close all closes everything or any other windows that are open from a previous program or previous code. The second line is the one that we used before, but this is like in a different way, because we're using specific sensors and specific libraries from Arduino. We need to define our like certain variables. We're gonna say, well, Arduino A is equal to Arduino, which is basically defining or setting up the connection with Arduino. But in this case, we're using a specific port, USB port, which is the COM7, which is the one that is connected to my laptop right here. And in order to know that, you can go to the Arduino. If you don't know it, you can go to Arduino and you can go to Right here, once you connect it, it's gonna show up here under port. It's gonna show up which port your board is connected to. Once you know that, you can just type it here, what type of board it is, Uno, and the libraries, and then Ultrasonic, which is this the sensor that we'll be using to do certain commands. Okay, we have to do this. If we don't do this, it's not gonna work, and they have to be in order as well. The second thing is we're gonna set a variable which will basically read. Ultrasonic sensor basically senses the distance of the object that is sit in front of it, and then it tells you how far it is from the sensor. So we're using an ultrasonic sensor which has this function in MATLAB, and then we're saying Arduino A, which is this variable right here, and then the number of ports or the number of slots that is connected to, which in this case is connected to the digital pin number 2 and the digital pin number 4. So we just set up the sensor and we defined a variable for the sensor which will fetch the data from that sensor whenever we want. The distance, which is basically the distance that the ultrasound sensor will read, will use the function called read distance, and we're using this object that we defined as the object. Our experiment, which we will be conducting in the lab, will be in a time frame of 5 seconds. Iteration number will be equal to 200. That's a user defined. You can do it more than or less than this. The time is a time vector that we are defining to start from 0 and to end at t, which is the 5-second frame. In between there are 200 numbers, which is the iteration number. What it does basically, the code will be repeated 200 times in a 5 seconds frame. It means we will be collecting the distance at this speed or at this rate 200 times per 5 seconds, which means 40 per second. And then once we define the time vector that we will be using, if we open an Excel sheet, we can actually look at what does this mean. We're making like 200 points of time here, starting from 0 and at 200, ending at 200 is equal to 5 seconds. And we're dividing all the distance in between to 200 points, different points. We do that using the linspace function or line space function right here. There is also another way of doing this, but there is a little difference, which is we can do time is equal to from 0 column 0 to 200, and we can put the time step, which could be something like this. So that's basically another way of defining it, but the difference will be how many points you need here. This will be a little bit different from this one. This one says I need only 200 points. So we're not gonna use that. We're gonna use the linspace function to do the job. Once we define our variables, we go to the functions of what the system will do basically, and we're doing that in a for loop. And in the for loop starts from this condition. It has an end statement right here. For time endent is equal to 1 to iteration number. So the iteration number is equal to 200, and the time endent is a new variable that starts with 1 and it ends at iteration number, which is the 200. So from 1 to 200 do this. So basically that's the condition, which is a repetition. So you're repeating for a certain amount of numbers, whatever is here, you write right here. So that's a repetition. The first thing is the color code is black. K is black, blue is B, red is R, which we'll be using here. So B means blue, Y means yellow, and so on. The distance, which is a variable we defined before, and we're defining it here again, which is we don't need this one right here. So you can just suppress that, making it a comment like this, because we're defining it one more time right here. Defining a variable inside a for loop is different from defining it outside the for loop. Why? Because for all the repetitions you will need to collect the distance at each repetition. But if you do it before the for loop, you're defining it only once and it will not repeat itself. So for all these iterations I am collecting the distance one time for each repetition. And then I will put this distance which I collected in a matrix called D, the D matrix. And what is this for? The D what is inside the brackets here is basically the index of this number. And what we're doing here is, if you go to the Excel sheet, this is the time column, or the time. It could be on the other, on the other direction. It could be columns instead of rows, okay? But it does the same job though. So for the first column, this is the time incidence, or the time indents, and this is the values that you're gonna collect for each repetition. What is the distance? You put it here. So we're making a vector. We're calling this vector D, and we're putting for each time indent, we're collecting the distance, and we put the distance in this column right here. So we'll have different like distances at each point, okay? So that's basically what we're doing. So we're saying, well, at which point at time indent, which starts from 1, as you can see here, the time indent starts from 1, 2, it's gonna repeat to 200 for each time. For the first repetition, the time indent will be 1. For the second repetition, the time indent will be 2, and so on until you reach 200. We will put in this cell right here the distance that is collected from the sensor. So for the first point, the distance will have a value, the second point, and so on until 200, the distance will have a certain value. The second thing is defining, well, we don't have to do that, but I just did it by myself. So you in your lab you don't have to do that, but that's basically, I'm defining the frequency to be relative to the distance that I'm collecting. So the frequency of the buzzer, which will make the sound, will be different depending on the distance. So if the distance is high, the frequency will be higher, so the voice or the sound that you will hear will be higher. So that's what this line is for. You can do that, and you don't have to do it, but it's just something fun to do, you know. So the second thing, we define those things, and then inside the for loop we have some conditions. What are those conditions for? Well, we're saying if the distance is less than 1, do this, or if it's not less than 1, then do something else and then end. And another condition, if the time indent is greater than 1, I'll tell you why we're using this one right here. It's not common, but we're going to use it because of something related to the code. So for each iteration, we're collecting data, we're collecting the distance, we're assigning the distance to each cell in the matrix, or in the D vector. We define the frequency depending on the distance. The frequency will have a different value. And then if the distance that we collected is less than 1, we're gonna make the led light turn on, which using this one that you used before, digital right pin, and the value is equal to 1, meaning light. And then we will play a tone in the buzzer, which will make sound, and play tone function does the job. Arduino, the number of the pin that you're using for the buzzer, and then the frequency, which you can just type in any number. If you don't want to use a variable frequency, you can just type in a number of the frequency, and the frequency basically decides what the voice or the sound will be of the buzzer. So it's gonna be like a high tone or a low tone depending on the frequency. And then we're doing that and then turn it off, because if you don't turn it off, it will be on all the time. So we're turning it on for just once and then turn it off. And then we will plot the color code, which will be used in the plot. If the distance is less than 1, we're gonna use this color code in the plot. So it's basically it's gonna make your if the distance is less than 1, the line will be having a red color. If it's more than 1, or else it will be a different color. Again, if the distance is less than 1, do this. Else, if this condition is not satisfied, you can use the else to do something else, which is basically turn the lid off. That's what we're using for. So if it's less than 1, turn on. If it's not, turn it off, and then end the if statement. The last thing in the for loop is basically the time indent. We're doing this to skip the first one. Why? Because we're using this value right here, or this statement right here, And this statement will not work if it's equal to, if time indent is equal to 1. So basically, when you use the plot, you're using two values. The first value is this, and the second value is this. So what we're doing here is we are assigning which one will be plotted. So let's say this and this. So this is the x value and this is the y value. And it will use those to plot. But in the time, because we're using like a time plot, which is the plot will be occurring, we're using two different points, meaning make a line between these 2 points. That's what our plot will be doing. And as you can see here, the plot is connecting points, right, using lines. In order to connect 2 points all together, you need 2 points or 2 indents, which will be the first and second all together. For this amount, plot this amount. But if the iteration number is equal to 1, it will not work. That's why you have to skip the first one. Look at this. If time indent is equal to 1, 1 minus 1 is equal to 0. And there is no cell that has the 0 number. So the cells starts from 1, 2, 3, and so on. Okay, so you have to skip when the time indent is equal to 1. And that's what basically the if statement right here is doing. Skipping the first one and the plot. You can plot from the beginning, but it's not gonna work. It's gonna give you an error because there is no cell number that is equal to 0. So why we're not using time indent directly without using -1 and then time indent? Because at the end you will have to do it, because you have to increment your time indent to plot this and this, right? So basically this is the time indent, which is 200, and the time indent -1, which means 199. So if you use, let's say, this time indent plus this, you'll end up having iteration number or the time indent plus 1, which will make the last iteration also not valid, because 200 will be 201. Iteration number plus 1 will be 201. So it will end up having either iteration number -1, which meaning this one right here, and this one, or the iteration number plus, which means this one plus this one. I mean, this one plus 1 will equal 200. That's basically the point. So we're plotting 2 points. We're using the first point and the second point next to it, and then on the D vector also we're using 2 incidents to plot these values. And we're using this type marker, which will be just the same as this one right here, and also the color will be the color code, which is defined here or here. So if the distance is less than 1, the color code will be red. If it's not less than 1, it will be, by default, will be blue, as we defined before the if statement. And after that, we're just labeling our plot, saying the x label will be the time, the y label will be the distance. And then for each iteration, we will pause for 0.1 second to just give ourselves some time to collect the data. Otherwise, it will take a fraction of a second to do all these things. And that's it. And then we end the for loop, and then we turn off everything, which is the buzzer or the lid light. Okay, in this case we're turning off the lid light. Yeah, so that's all. I don't want to say more than that to make the video short.